Good evening, Titans, and welcome back to Algebra 1's Flipped Classroom. This is Mr. Simpson, and we're going to be starting Chapter 10, and today we'll be looking at how we graph parabolas and how the equation of a parabola is different than the parent graph. First of all, just the quick definition of a quadratic function. Remember what quadratic means. Quadratic means second degree. So we want to make sure that the equation has the highest power of the variable to the second power. And again, this is just the generic form y equals ax squared plus bx plus c. We will look at different forms as well today. First of all, the parent graph of a quadratic function. Again, this graph is called a parabola. And all second degree equations will have a similar look to this, which is called a parabola. Now this particular graph is the parent graph, which means all the graphs that we're going to look at are going to originate from this parent graph. And so if we look at the t-chart we have here, and if I plug values in for x, if I plug 0 in for x, 0 squared is 0, I get the ordered pair 0, 0. If I plug 1 in, 1 squared is 1. If I plug negative 1 in, well, negative 1 squared is also a positive 1. If I plug 2 in, 2 squared is 4. If I plug negative 2 in, well, remember, it's negative 2 to the second power, which is negative 2 times negative 2 would be a positive 4. And if we go ahead and look through the whole chart, you can see how then this graph is created. And a couple main things here. This point right here, which we kind of talk about where this parabola starts, is called the vertex. In this particular case, it's a minimum because it's the lowest point of my graph. And then notice that the graph is the same on both sides of this red line, which means the graph is what we call symmetrical. All right? And symmetrical means that if I would fold the graph along this line, the two halves would match up. And this red line is called the axis of symmetry. Now, the form that we're going to be working with to graph parabolas and show how they're different from the parent graph is what we call vertex form. And this is one form of a quadratic function, which is y equals a times the quantity x minus h all to the second power plus k. And when it's written in this form, this hk, the hk is the vertex. The h will tell us if it moves left or right, and the k tells us how far it moves up or down. The line x equals h is the line of symmetry. If this a out in front is positive, the vertex, or excuse me, the parabola is going to open up and like smile. If this is negative, then it's going to open down like a frown, and we call that a reflection. And then we look at the value of a. And if the absolute value of a is greater than 1, meaning it's a number like 2, 5, even negative 7, because again the absolute value of that would be greater than 1, then it's going to be skinnier than the parent graph. It's going to be a vertical stretch, really skinny. But if a is a number less than 1, like 1/2 or 0.3 or negative 0.25, then it's going to make the graph wider than the parent graph. All right? So here's just a key skill, and we will have to graph them. We'll also have to determine where the vertex is, and we're also going to have to determine how is it different from the parent graph. Well, this first one, if we look at this, we first like to identify the vertex, and this is x minus 7, so the h is 7. And again, you may get confused here. Why is the x value 7 when it says x minus 7? Well, again, it's in the form x minus h, and h is what we use to determine how far it shifted left or right. I like to think of it as what value would make n for x would make this inside here go to 0. Well, 7 minus 7 would make that 0. So whatever value I have to plug in for x to make the parentheses go to 0 is my x coordinate. And then whatever the value is on the outside is my y coordinate. So in this particular case, my vertex is at 7, negative 9. And then my axis of symmetry is at x equals 7. And then I can make my graph. And again, we'll talk a little bit more how we make our graph, but usually we would use a t-chart and plug in two values to the right of my vertex. So since the vertex coordinate is 7, I'd plug in 8 and 9 to find y values that pair with that. And I'll demonstrate that later in the video. So here, we're not even worried about graphing it. We're just worried about describing how is this different from the parent graph. So the first thing we're going to look at is inside the parentheses to determine does it shift left or right. And since it's x minus 5, it's going to shift 5 to the right. And then the minus 2 means it's going to shift 2 down. And now I'm going to look at the outside number. And since the outside number is positive, it's going to open up and smile at me. And then because it's a 3 and 3 is greater than 1, it's going to be narrower than the parent graph. All right? So now if we look at number 2. Again, first thing I look at is on the inside, and since it's plus 2, it's going to be 2 to the left, because a negative 2 would make that 0. And then the plus 1 means it's going to shift 1 up. The negative means it's going to open down like a frown, so that's a reflection. And then because that's just a 1 out in front, it's going to be the same shape as the parent graph. It's not going to be wider or narrower than the parent graph. It's going to be the same shape. So that's one of the skills we have to be able to do today on your assignment. Now, the next thing is to be able to graph it. So again, we're going to go through a lot of the same things, except here the most important thing is to identify the vertex. So the vertex is going to be at 3, negative 6, because it's shifted 3 right and 6 down, so I'm going to graph that. And now I'm going to have to use a t-chart. I know it's going to open up, and I know it's going to be narrower, but I'm going to use a t-chart. And since my x-coordinate is 3 and my line of symmetry goes right here, then I'm going to use two x values directly to the right, which would be 4 and 5. So if I plug 4 in, and again, when I plug it in for x here, I'm just using order of operations to evaluate. 4 minus 3 is 1. 1 squared is 1. 2 times 1 is 2. 2 minus 6 is negative 4. Now I'm going to plug 5 in. 5 minus 3 is 2. 2 squared is 4. 2 times 4 is 8. 8 minus 6 is 2. And now I graph those 2 points. So I have 4, negative 4. And I have 5, 2. And then I'm just going to use the line of symmetry to pick the points that would be on the other side. And now I just make a sketch of my graph. All right? And then we'll go ahead and take a quick look at this next one here. So I'm going to erase this one. And let's take a look at this next one. Again, the vertex in this case would be negative 3, positive 4. So I graph that, negative 3, positive 4. I make my line of symmetry right through that. All right? And now I know it's going to open down because of the negative, and it's going to be the same shape, but I'm still going to use two values to the right. So I'm going to use negative 2 and negative 1. So if I plug in negative 2 for this x, negative 2 plus 3 is 1. 1 squared is 1, times the negative is negative 1, plus 4 is 3. So I have negative 2, positive 3. And now I plug in 4, or excuse me, I plug in negative 1. Negative 1 plus 3 is 2. 2 squared is 4. The opposite of 4 is negative 4 plus 4 would be 0. So I have negative 1, 0. And now again, I use my line of symmetry, and now I just make a quick sketch of my graph. Those are the two main skills that we're going to focus on tomorrow in class. So we're going to have to determine how is the equation given to us in vertex form, how does it make the graph different from the parent graph, and just to be able to describe how it is different. All right? So that brings us back after our long spring break and gets us back into the swing of things. So enjoy the rest of your evening, and see you tomorrow, Titans.
Made with Doodlecast Pro.